So we have officially and thankfully covered Unit 4 in the previous session. Now, as I've said multiple times while we were covering Unit 4, that doesn't offer the best explanation in the text, and at many a times it probably felt confusing. A number of things were to be taken just as they have been presented. So it's something that they're telling you happens and you say, okay, fine. Or they're telling you the way something works and you're also, just late, accepting that. Uh, One of the problems is that because they've left out explanation for a number of things which is causing the confusion, the explanation is actually beyond your O level syllabus. So if we get into that, even if it does offer clarity, so to speak, it might be more for you to handle and obviously beyond your syllabus. And it, there is the chance that it might in turn cause confusion as to what you need to know and what you don't need to know as far as the syllabus is concerned, because at the end of the day, it is an examination. You are preparing for an exam. So the exam has certain requirements, it has certain demands, and you're supposed to fulfill those demands. So yes. So if in case when we are done with the syllabus and we move on to past paper practice and we need to revisit a topic, we will do that. And if we need to go over the explanation for clarity, then we will try and do that as well, right? Because that is our primary goal. So if we can manage, well and good. If not, we will revisit and see if we can do any better. All right.
Yes.
Now we have come to section 5, which is a short section, and so is section 6. So we actually made it through the longest one and the most challenging one, I believe. And so now we are going to talk about nuclear physics, right? And since we're familiar with this from chemistry, when we say nuclear physics, perhaps what comes to mind is, nuclear reactors and uh, nuclear reactions and power stations and stuff like that. And all of that, all the nuclear that they're talking about is based on the nucleus of atoms.
I think we did that we talked about this in the earlier chapters. Something about nucleus?
Uh, if we have, sure, but right, just clarifying that. So the first thing we're going to talk about under nuclear physics is the structure of the atom. And we're going to cover some stuff that we have done earlier on in chemistry. So we know that the nucleus, I mean, the atom has a nucleus that contains the protons and neutrons, and the protons and neutrons give the atom its mass. Electrons orbit around the nucleus, and they don't contribute to the mass of the atom, right? So we are aware of all that, but now we're going to take a look at it from the perspective of physics. And the first thing we're going to do is something that wasn't covered in chemistry, and that is how the modern model of the atom, right? So how the nucleus surrounded by electrons, right? And so you've got the positive and the neutral over here, the protons and then neutrons, and then the electrons. So for example, this is helium, right, with 2 electrons. And so how the atomic model was discovered, so to speak.
Okay.
So much earlier on, there was a theory called the plum pudding model. Sounds nice.
Yeah.
And what this suggested
Sweet.
is, yeah,
Sounds sweet.
yeah. And what this suggested is that the atom was a sphere of positive charge. So this whole thing had positive charges throughout it, evenly distributed. And the electrons were like, they call it black currants. You can call it raisins, perhaps, if you had, cake with raisins in it, right?
Yeah.
And so the electrons were like black currants or raisins that were distributed throughout this cloud of positive charge, right? And electrons distributed through it. So this was the initial, you know, model that was suggested. Now, through various experiments, scientists began to doubt, right? Acha, one more thing is, according to this model, the atom was electrically neutral, right? Why? Because the positive charge was spread throughout and the electrons were distributed throughout, so positive and negative sort of cancel each other out, and so the atom had no charge, right? And as I said, through various experiments, the results that other scientists got, they, were doubtful that, this might not be the proper way that the atom is structured, right? So way back when, a scientist named Ernest Rutherford, he conducted an experiment called the gold foil scattering experiment, right? And what he did was he took a very thin, not thin, thin foil of gold. And so even if you have like a very thin foil of gold, it has atoms in it, obviously, right? And he shot something called alpha particles at high speeds at the foil, right? And alpha particles are positively charged. Okay.
Yes.
And then he set up the experiment so that he could detect the alpha particles passing through the foil. What he noticed was, and how, like they mentioned, right, there was a rotating microscope with a zinc sulfide screen. So what happened was, when the alpha particle hit the screen, right, it would cause a bright spot. So that detail is given in the book. I'm just explaining to you how this works. What he noticed was that, right, so those bright spots are called scintillations. Okay. uh, Again, what he noticed was that the majority of the alpha particles passed through straight, undeflected, right? So the majority of alpha particles passed through straight. Some were deflected, and that means they were coming in and then they were moved by some angle. Okay. And
Yes.
very few, so they give a number like 1 in 8,000. 8,000, yeah, right? 1 in 8,000 was bounced back. right? So it came in and then bounced back. And so based on these observations, and he did some calculations and stuff like that, what he suggested was the nuclear model. So from the plum pudding, now we have the nuclear model, right? Which suggests that the positive charge of the atom is concentrated in a nucleus in the center of the atom, and the negative electrons are arranged around the nucleus. Right, so uh, why is this happening? This was happening, why? Because if we represent the gold atoms like this, so we have yellow, so let's use that. Oops, the atoms are getting bigger. Try to keep them uniform. And let's say these are your gold atoms, right? And so they've got a positive charge in the center. It's probably not very visible. And you're shooting your alpha particles. So alpha particles are positively charged, right? And so from charges, we know that like charges repel each other and unlike charges attract each other. So you've got a positive charged alpha particle and it's being shot at, I can use this for a straight line, right? And so when the alpha particles are passing away from the nucleus in between the atoms, they're passing straight through. Okay, so away from nucleus, in between atoms. Then you have some of them that are closer to the nucleus, right? So they're coming in, they're not at the nucleus, but they are closer to the nucleus. And so what happens, right? Remember, alpha particles are positively charged. So when they're close to the nucleus, they're going to be repelled by the positive charge of the protons, and so they're going to be deflected. Right, so these guys are close to nucleus, and so obviously the closer to the nucleus they are, the more the repulsion will be deflected due to repulsion between charges. Right, alpha particles are positively charged. Then you had the guys, very few, that were coming in directly at the nucleus. And so if they're approaching the nucleus directly, very strong repulsion, and so they're going to bounce right back. Right, so they are towards nucleus, which is where the protons are, right? I mean, we call them protons later, but where the positive charge is, and so they are bounced back or reflected, so to speak.
Okay.
So this is what was happening. Okay.
Yep.
So now for the IGCSE, it's given as a going further thing, but in the O level, right, they mentioned this, that later on again there was another scientist by the name of Niels Bohr, and he extended the experiment Rutherford conducted, and finally the model that we follow now is called the Rutherford-Bohr atomic model. And so he suggested that there were protons and neutrons in the nucleus and electrons in orbits around the nucleus, right? He also talked about, since I mentioned again, for the IGCSE it's going further, but for O level it's part of the syllabus. He also mentioned that atoms can emit light or electromagnetic waves depending. So, right, atoms can emit electromagnetic waves of different frequencies. In fact, different wavelengths, not frequencies. So you can have X-rays or infrared or ultraviolet or gamma rays depending. Now what it depends on is that electrons are in orbit, right? If they gain energy, they can move to a higher orbit, right? So if you've got, for example, two orbits over here, not making the nucleus, and you've got this guy over here and it gains energy, so it's going to move to a higher orbit. It's going to be over here. And it's not going to stay there, right? The only reason it moved to a higher orbit is because it gained energy, right? So it's going to lose energy and go back to its original orbit. And while it does that, during that, how is it going to lose energy? It is going to emit some electromagnetic wave. Now, which one it emits depends on the difference in the energy level of the orbits. So how high did the electron jump, right? That's going to determine whether the electromagnetic wave that is being emitted is light or ultraviolet or X-ray or whatever. Okay.
Okay.
So I don't believe that was, very challenging or confusing. Yeah. And
Yeah.
and we know details about the atom from chemistry as well. So, right, that is about the model of the atom. Next up, we talk about ions.
That's more?
You want to stop?
Yeah.
In fact, let me just talk about the ion because they're not talking a lot.
Okay.
Right? So what ions are is if electrons, an atom is normally neutral. What this means is that the number of protons equals the number of electrons, right? But what can happen is the atom can either gain or lose electrons, right? And so if it loses an electron, right, the number of positive particles, which are the protons, is greater, or in fact, I should use the greater than sign, than the number of negative particles, right? And so what happens is that the atom develops a positive charge. called a positive ion. Again, we know that from chemistry. If it gains an electron, right, the number of protons is less than the number of electrons, right? The atom becomes negatively charged, it becomes a negative ion. And among other things, this concept is obviously we've learned ionic bonding in chemistry. So that's where this comes into play. I'm hoping there's no question about this part. Should be pretty clear. Yeah.
Yes.
Right. And we'll stop here. So I just wanted to kick off unit 5, and we've done that. The next time we'll talk about the nucleus, which is again something we know very well, but since it's here in the syllabus in the book, we'll talk about that. Isotopes, again, we know about isotopes. Then we'll talk about nuclear energy, which is going to be new. And then after that, radioactivity. And as I mentioned, it's a short unit. So hopefully we'll be able to get through all of this the next week. And then we'll be left with unit 6, section 6, which is space physics. Then we'll be done. So hopefully we will meet our target of completing the syllabus by the end of Feb. If not, at most the first week of March. So that's not too bad.
Okay.
All right. I will
Yep.
see you guys next week.
Yeah.
Okay then.
Allah
Allah Hafiz.
Allah Hafiz.